Question 10, part A. Simplify 27y to the power of 6, all to the power of 2/3. So using the distributive law, when you have a product to a power, you can apply those or distribute those powers to each part. So that's the first step I'm going to take here, which is 27 to the power of 2/3. And then we have a y to the power of 6 to the power of 2/3. When we have 27 to the power of 2/3, we can just type that into the calculator. Technically, we end up with a cube root of 27 for 3, and then we square that for 9. So 27 to the power of 2 cubed, 27 to the power of 2/3 is going to give us 9 as our answer. And then for the other part, y to the power of 6 all to the power of 2/3. When we multiply those together, we get 4, meaning that that is our new power of y. And of course, because we're multiplying these two things together, we just stick them together to give us our final answer of 9y to the power of 4. Part B. Giving it 2 to the power of p times 8 to the power of q equals 2 to the power of n. Express n in terms of p and q. Anytime you have letters and powers at this stage in your mathematical careers, how you're going to deal with solving an equation, or in this case expressing a formula, is you want to look at all the bases that are involved in the question. So our p is a power of 2, so 2 is our base. Our q is a power of 8, so 8 is the base, and our n is a power of 2, because 2 is the base. First step of solving these is to rewrite every single one of these as the same base. Now we have that already for the p and the n, because they're both 2's. And generally speaking, the smaller the number, the more you can be sure that there's nothing to do with it. However, that 8 can be written differently. That 8 can be written as a 2 to the power of 3. So that's exactly what we do. By doing that, we have now made all of the bases the same. All of the bases here are now 2's. And because of the fact that all of that 8 had a power of q, I've put the 2 cubed in a bracket, and then I've wrote q as the power of that. Once you have everything in the same base, what we do is we simplify both sides using our laws of indices. So right here we have 2 to the power of 3 to the power of q. We can multiply those together to give us a 2 to the power of 3q straight away. We still have this 2 to the power of p, and we still have this 2 to the power of n. Then, next step, because I'm multiplying bases that are the same, I can add their powers. So I'm going to end up with a p plus a 3q. On the other side, I have a 2 to the power of n. And when you get to the stage where you have written everything in the same base, you've fully simplified both sides, you're going to end up with something like this. We have a 2 to the power of something equals a 2 to the power of something, which basically means that you can set the powers equal to each other. So I know that p plus 3q equals n. So p plus 3q equals n. And then the question itself is asking us, what is n in terms of p and q? Well, there's nothing more to do here other than write this the other way around, because n is p plus 3q.